Hi, my name is Will, and today we're going to talk about tips for dealing with legacy code. So first off, my name is Will Iverson. I've been doing Java since 1995, and I've been doing consulting since 2000. In that period, I have done countless migration projects for everything from startups to Fortune 500 companies. So first of all, what is a legacy system? And the first way that you know that you have a legacy system is that almost nobody wants to work on it, and almost nobody understands it. Another way to look at it is, does it have a test suite or not? There are some people who find legacy code as code without a test suite. And then finally, a legacy system, because of the problems that it has, technically, how it was built, architected, whatever, it's starting to affect the business being able to operate. Technically speaking, a system that's in place that works, that people still work on and works okay and allows the business to do what it is that really a legacy system or not? That's a philosophical question. But clearly, if no one wants to work at it, has no test suite, and the business can't get what they need done, it's almost certainly a legacy system of some kind. That gets into the first point, which is clarifying the goals. Why do you want to switch? So be clear about what it is that you're trying to do. For example, are you switching because you can't get maintenance anymore on the app server that was used, and now you're worried that if there's any future problems, you won't be able to get support? If the goal is to move off of, say, an old Oracle system because it no longer does what the business needs it to, then you need to write that down so that way everybody who's involved with the project or the work knows what's going on and why. And part of that also may get into a question around timeline. And this is where things start to get interesting and potentially challenging. So let's say that you have an annual maintenance fee that you're paying, and you really, really want to stop paying that fee. So you want to move off of an old system by a certain date so you don't have to pay the fee anymore. That implies potentially getting into a situation where you're going to have to deal with a big bang cutover. The clarity around the timeline and why you're trying to hit it is very important for everyone involved. So that's the first thing. Always make sure you know what you're doing and why, and everybody on the team is on the same page. The next one is when you're looking at the legacy code, especially if it's somebody coming in to do an analysis, to start evaluating it, and you need to know what you have. And that may be something where it's important to bring an outsider in, say another engineer from a different team or an independent consultant, to look at what you have and be able to give you an honest assessment about what even the system has. I'm going to give you an example of where this can sometimes be confusing. I was once asked to review what was described to me as a C# web services project where the client wanted it to be modernized. And what was very interesting was once I actually got the code and started going through it, easily 95% of what was in the project were actually stored procedures. So they were SQL Server stored procedures, but it was described as a C# project. And really what the C# code was doing was just being a little web service shim. The next part is to go through all of the files that are in the project. So if there's a Git repo, or maybe a CVS or a Subversion repo, or whatever the heck it might be, you really ought to, as part of the inventory process, just go through and view every single file in the project, just to make sure that you can kind of have a high level sense of what's in there. And so part of what that means is being able to develop as a skill, the ability to go through a large code base very quickly and use different kinds of tools in order to get some sort of a sense of what you're dealing with. One of the keys, or one of the tricks that I've found, is generally speaking in old legacy systems, there's often a handful of files that kind of have gotten away from people. So you'll find something where it's like 3,000 lines or 10,000 lines of code in a handful of files. And that's how you sort of start to get a sense of where some of the heart of both the app and the problems are going to be. Next tip, build. Do you know how to create a fresh build? If you don't, then what the source code really represents is a whole bunch of legacy requirements that just happen to have been written in source code form. That doesn't mean that it's not important. You'd be surprised how many little tiny things are hidden in those files that represent important business requirements that people may or may not even realize are in there, or where they came from, or why they're critically important today. First, try to get a build, and if you can't, at least view the app as a requirement set. One of the things that you'll see when you start going through these build scripts is some standard patterns, especially if you see a lot of these. You'll see that build scripts will often refer to tools that don't exist anymore. So you might have an application that you think you've gotten all the code for, but it's missing the installer scripts or the build scripts. It might have the references to files that were never actually checked into source control. This is sadly more common than you'd think, that there's a single developer's machine that might have been used to build or release applications that had configuration values on it or tools that are now gone. The system was wiped, doesn't exist anymore. Often there'll be environment variables or configuration values that are missing that are key to get the actual app to work and may also not be very well documented. Once you've got all those assets, you know what's in there. Now your next step is to stabilize. So think about this almost like an ER room where you have a patient that's now bleeding out on the table. Your first step is to just try to get the bleeding to stop. One of the very first things that you're going to want to do is make sure that at least the assets are in a source control system and a modern one. The next thing is verify if there is an automated test suite. Now, this is a little facetious because of course you don't have an automated test suite. I don't think I've seen a legacy application that had an automated test suite in years. And starting now, I can see those things starting to come into play. So an app that might have been written 5 or 6 years ago may include a handful of test cases. But generally speaking, there's no automated test suite. You might ask and see if there's a manual test plan. And more often than not, there isn't, or of course it's hopelessly out of date and doesn't match what's in the code anymore. Ideally, if you have a build and you're still able to work with it, you might want to think about what can you do to at least build what most people today would call a smoke test. And that's basically just, can you launch it, log in, perform a few functions, and just verify that all the components are talking to each other. If it's a web app, can it talk to its database? That kind of thing. You might want to, as part of the stabilization effort, go ahead and create some automated tests just to get a flavor for how the system works from a technical standpoint. Now, depending on the application or the environment, that may or may not be feasible. In a few cases, I've been very lucky, and I've seen that there were a handful of flows that represented kind of the happy path, and I was actually able to build some automation around just a handful of test cases and get to 30-40% code coverage very quickly. But that's kind of rare. And part of the key there is to isolate out any of the GUI from the underlying code and logic. Sometimes you're lucky and there'll be a folder labeled GUI and a folder labeled business logic or something like that. That's not very common, but you never know. Maybe you'll get lucky that way. Next tip, and this one's huge. You need to set the expectation with everyone that's involved that you're going to have dual systems during a transition. What you'll see is that people almost always gravitate initially to doing some kind of a big bang cutover. And they will come up with a lot of reasons why that's important. And we'll talk about some of the strategies and the reasons and the issues in a minute. But I cannot emphasize enough to avoid trying to do a big bang at all costs. That is one of the quickest ways to box yourself in on your scope and your timeline and your resourcing in a way that now you've locked yourself into an iron triangle that you can't break out of, and it will bite you. This is probably one of the hardest parts about dealing with legacy systems and migrations, is that folks have to accept these dual systems. And if I had to pick one piece of advice on this for management, it's to not link performance reviews to getting these big bang cutovers done. You'll see people do this, especially if it's non-technical senior management. What they'll do is they'll just go to everyone in their organization and they'll tell them, you have 9 months to make this transition happen. Decommission the old system, have the new system. And what's weird is that might be linked to some kind of licensing revenue component. So maybe there's a legacy database vendor, and right now the business is writing a check for $250,000 a year, just cash every year for maintenance on the system. So then the VP says, well, we want to hit our milestone and everybody needs to kill the system by this date, because then I can show that I've made these savings. And in a few cases, it might even be worse. I've seen 7 or 8 figure licensing that's driving why the business thinks they need to do the cutover. And that can be a very hard conversation to have about doing the big bang cutover, but also not screwing up these performance reviews. Now, I'm going to throw out one little anecdote really quickly. There was one time when I was hired by a client to do an assessment on an existing legacy system. And what they wanted was an estimate from me on how much work it would take to cut over. So I did the best I could. I went through and added up how many features were in the system. I sort of normalized that to how many CRUD operations there were. And then I came up with the spreadsheet for a model for how much work it would be to port the system from the old one to the new one. And I think it came out to about 3 million, which was a pretty wild guess, but it still had some data to back it. Now, what's really interesting is the licensing fees for the system were something like 7 or 8 million. And the VP of the group was able to use that assessment to go back to the vendor and negotiate the licensing fees down several $1,000,000. So a few weeks of work on my part to do an assessment on what it would take to be a porting engagement wound up saving the company millions of dollars, my client, but we didn't actually get the development work out of it, right? Because the vendor cut the prices and then they wound up deciding not to do the porting effort. So creating estimates and understanding what the purpose of the estimates are can be very important, but don't try to use that as the basis for performance reviews for doing a big bang cutover. Which leads to the next part, which is don't switch multiple layers of an application at once if you can avoid it. So let me explain what I mean by that. Let's say you have a legacy Java struts application. So struts is an old Java web framework that hasn't been in use for over 10 years. But it was very popular for a period of time. And it was often combined with, say, an Oracle database and an older, potentially an even older data model. So the first reaction a technical person might have to seeing that system is to just throw it all out and start over from scratch. If you try to do all of that at once, you may wind up with a project that can take years to do. And then now you have no real wins because you're in the middle of redoing everything. And it can take years. This will lead to frustrating everybody, including whoever's part of the business, who originally maybe even was the ones who were asking for this port in the first place. And most importantly, for senior management, this is actually, I think, one of the quickest ways for senior management to wind up fired. Trying to do too much at once because you've taken on too much ambition without adequate planning. So keep it smaller, pick one thing at a time, and try to be more focused and coherent, right? Let's take that Oracle example. So let's say that the target is a Spring Boot app running on Postgres, right, with a new data model. So if you do one piece at a time, now you have a way to break this up. So let's say that the first thing that you do is you say, we're just going to convert from struts to Spring Boot, but we're not going to touch the Oracle backend, and we're not going to touch the old data model. We're not going to deal with any of the stored procedures or anything. All we want to do is just take the existing struts app, get rid of it, replace it with something clean and modern like Spring Boot with a nice Spring data interface, right? Once you've done that, as part of that process, you're also writing out all the automated test cases so you know what the heck this thing's even supposed to be doing. Okay, next, you then maybe move it from Oracle to Postgres, but you're trying to not change the data model. Well, now you have a real asset for being able to do that, which is the Spring Boot's test suite. So as you convert over from Oracle to Postgres, you can run the test suite, and that will help you identify what's broken in the app as you're trying to do the switch. Then finally, once you've got switched over to Postgres, now you can start using refactoring tools and modern migration tools to manage switching and updating the data model, right? So now instead of having maybe a 3-year project that winds up with the VP of the group getting fired, you have a project that now you can take into small chunks and you get wins at every step. You get a win when you retire the old struts code, you get a win when you switch from Oracle to Postgres, and then you get a win as you clean up the data model. Part of that comes back to not throwing it out. Try to avoid making those pitches of blowing everything away and then rebuilding it from scratch. And one of the ways to do that is when you're starting to talk about doing a rebuild, you should probably assume it's going to take as long to do a rebuild from scratch as it took to originally build. So if it took 5 people to build that app and it took them 5 years to do that, you should probably go ahead and estimate a 25 person year effort to be able to do that work. So you may say, why? Why don't just throw it out and start over? Okay, more often than not, for one, you're often dealing with a change of the team and the change of the members. And so that means that you're having to rebuild the domain expertise, right? So that simple and easy quick migration from the old Oracle system when half the people or most of the people who built it are gone means that now your development team's just even having to ramp on what the heck you're trying to build. On top of that, the requirements are still going to keep changing through your development cycle, kind of no matter what you do. More often than not, the business will come back and they'll still want to make changes or features. And if you open it up with a rebuild, now you're going to be pursuing multiple goals. You're maintaining this new system, you're maintaining the old system, and you're also trying to get feature thrash going at the same time. Trying to do all of that while you've also thrown it out and you have 2 completely different independent systems that don't talk to each other, don't deal with each other, they're just existing. It means that the old stuff that you threw out and the new stuff is just never going to sync up. And if you try to lock it down, the business will get annoyed. And that comes back to that point earlier about if you're trying to do all the layers at once and then you try to lock it all down, 3 years of telling the business no new features is not, generally speaking, going to work out for anybody. And the last piece is on that effort is don't underestimate how much the users of the application will be affected by the rebuild. Not just the developers, because you're also potentially having to retrain them as well, but even the end users. So let's say that you're working on an app that's used by a customer service team of 100 people. So as you're making changes, you also need to be rolling out those changes to the end users. If you throw everything out and do a complete rebuild, in addition to taking all that time, now you're also having to train everybody. So who's going to do that? How are you going to manage it? Next is the Pareto Principle, which you'll sometimes hear is referred to as the 80-20 rule. And basically the idea is that when you're going through the old system, more often than not, you'll find that there's one flow or a handful of flows that actually cover the vast majority of the things in the old application. And this isn't true for everything, obviously, but if you can hook up an analytics to the old app, if there's some way to track the usage, more often than not, what you'll find is there's certain workflows that are really key to the business that cover a lot of the usage, and that might be a very small chunk of code to port. So instead of saying, oh, well, we're going to port the whole app, maybe you just focus on the key things and leave the old legacy system as sort of the advanced users only, or, something that maybe you move to a second tier of access for a while. So that becomes an interesting way to stack rank and prioritize the work while you're also doing these migrations. In the best case, maybe it's a legacy web app. Like let's say you've got, for example, an old PHP app, right? And you've decided to move that to a modern framework or a modern system. So it actually is really clean more often than not to map those old pages to a page-by-page migration model. Almost all these old frameworks, you can add some kind of a redirect system in, and then you can pick one at a time and cut the pages over. Now, I'm going to throw out a framework. There's a thing called HTMX, and HTMX is a way to essentially have a web page that can then include chunks of HTML from another web page. This can be a way to take a page, maybe a very complex page that's doing a lot of work on it, and let's say you want to take chunks of that and start moving them to the new framework. HTMX can be a great way to drop chunks of content from a new service into an old legacy page. Highly recommend checking it out. Links in the description and all that, but you can just search for HTMX and find it. So then by adding redirects one by one, you also get the advantage of taking load off of the existing app. So one of the most obvious reasons why someone moves off of a legacy app is because it's buckling under the performance issues. And so by slowly phasing out page by page, that gives you a really clean way of being able to move off. Now, the worst case situation for legacy code is often either legacy mainframe or old school desktop UIs. So for the mainframe, That's a huge topic. And one thing that does exist that most places have is that they've actually created a model for bridging the old mainframe data with some kind of web services. And there's a lot of different technologies that do that depending on the package. But key to that is truth. And what I mean by that is the mainframe is often what's referred to as a source of truth for certain parts of the system. And really what you're trying to do as you move away from the mainframe is to pull little chunks of the source of truth out of the mainframe. And that requires going in and understanding the old mainframe data model and then what you're trying to accomplish with the new thing. So it's a piece-by-piece way of breaking up what the responsibilities are of the mainframe system and beginning the process of moving that to a new package. So that's a huge topic. It's just one of the highlights that I would focus on. Now, desktop GUI apps. So there's a lot of these different technologies that were used back in the day. It might be Visual Basic, Swing in the Java world is a very popular one. You may have this legacy app existing that you want to port or modernize. And the strategy for that is going to vary depending on the tech stack. Now, since I've been doing Java since 1995, I'm very familiar with the Swing and AWT and Java FX world. And what I would say on that is the first thing to do probably is actually just to modernize the app. More often than not, a Swing app or a Java FX app or what have you can actually be brought up to speed with modern desktop systems pretty quickly with just a few improvements. And often that includes updating the build system, how the installers work, switching to a modern JDK, adding in, signing and notarizing and stapling on macOS and Windows. And then also updating the UI. And there's a package called Flat Look and Feel, which is a great package for doing that. And once you've updated and modernized that Java app to a modern build system and all these other pieces, and then you've kind of locked it down a bit. And that may include a bunch of refactoring work, which can be tricky if you don't have a test suite. But if you can start to refactor it out, what you'll find is that there's a lot of core business logic in that Java code. And what's kind of cool is that then you do have the option to migrate it, for example, to a modern Spring Boot UI. Other than that, depending on the platform that you're working with, the modernization path may look differently. So the best way to handle a VB app migration may be different from, say, the Power Builder app or some other legacy framework that you maybe have never even heard of. It just depends. You have to go in and look at it. There's really no shortcuts. And the last one, when you're doing a migration, what you'll find more often than not is that the system has a convoluted notion of identity. And what I mean by that is, does it have its own weird login system? Does it have its own separate little user table of data? And that often is one of the first things that I would recommend trying to break out of the legacy system and make sure it's up on some sort of independent new system. So that obsolete identity system, maybe it's got security problems with it. It might be a username and password, but then you'll find out that the password's being stored in clear text. So now you have a huge security problem just waiting for you. The identity system may not talk to anything else. And so now you're going to have to introduce new synthetic IDs in order to, or the existing identity system may not match the identity in other systems, and that may even be one of the big problems that people have with the legacy system. So that's often one of the first candidates for breaking out of a legacy system, is to try to make it no longer a part of managing the identity of the user. And then that gives you a way to start thinking about how you migrate the data off the system. As a side note for that, JWTs are a way of passing identity around with cryptographically signed tokens. This is another whole presentation to go into detail. But what I've found is that JWTs can be a really good way of managing the flow of identity in a way that will work both with modern systems, and you can often get it to work well with a legacy system as well. So it's a way of simplifying how you deal with trust by using these little cryptographic tokens that you pass around. It's really cool. To summarize, this is the list that we just covered. Stabilize, maintain dual systems, do one layer at a time, don't throw it out. Focus on the 80-20, look for the hot spots in the existing app that you may be able to get good wins out of early. Page by page if it's a web app, source of truth for mainframes, modernize and migrate for desktop GUIs, at least on the Java side. And then finally, think about your identity service. All right, there you go. Thanks for watching this video. Feel free to reach out. I've got contact information in the description, and let me know. I'd love to hear both your horror stories. Tell me what about migrations that went really well. It's always fun to hear from folks. And of course, if you need any help with something like this, feel free to reach out. Thanks. Take care and bye.